Hi everyone, welcome to lesson 7 today. We got solving exponential and logarithmic equations. This is our 7th lesson of our exponents and logs unit. We're going to start off with our opener question today. So it says the expression in this long logarithmic expression is equivalent to, and you're matching it up to A, B, C, or D. So this is a multiple choice question. So what should we do here? We should try to probably rewrite this logarithmic equation as one giant log. I'm noticing that I have an x here, x here, x here in the first three terms, a y here in that fourth term. I'm looking at my answers. I see y is always by itself there, so most likely I'm not going to combine this log base 2 of y with any of these base 2 of x's anywhere, okay? So I'm just going to keep that separate. Let's go. So to start off, I'm going to start off with log base 2, as everything was log base 2. X plus 2x just really means multiply, so I'm going to start off with my bracket. X multiplied by 2x there. I see this subtraction, which really translates as a division in our logarithmic equation here, so it's going to be divided by x squared, close bracket there, and I'm going to keep this minus log 2y on the outside and by itself there. Here I'm going to try to clean up this equation here. So really this is x times 2x, which is now log base 2 of, I have 2x squared up top, all divided by x squared on the bottom still, minus that log base 2 of y on that outside. Here I can clean up. My x squared and x squareds will cancel each other out. So I'm left with now log base 2 of 2 minus log base 2 of y. And again, base 2 of 2, this is one of your special cases. This is always equal to 1. So I have 1 minus log base 2 of y, and that matches up exactly with D. There we go, that's our opener. Just an FYI to speed things up in the future, if you ever wanted to use this to solve this on your calculator, you could easily sub in an x value and a y value, and then see which one of these match up with one of these down here, and you just sub in numbers, and it should work out that way as well. Here it says review, we're solving exponential with a common base. So here if I see 25 and 5, I know that I have a common base. So what I need to do first is convert them both into common base. So I'm going to convert both of these to common base 5. This one here on the right is already done for us. Over here we're going to start off. This is 25 is the same thing as saying 5 squared. And I have my x plus 1 on the outside of that there is equal to 5 to the 3x minus 1. Now that we have common bases, what can we do? We can drop our bases. So I'm going to drop my base and distribute in at the same time because we have a single base on each side, so I can drop my base. So I have 2 multiplied by x is now 2x, and then 2 multiplied by 1 is just positive 2 here on the left. This is equal to 3 multiplied by x, which is 3x, and 3 multiplied by negative 1, which is negative 3. And again, just an FYI, I'm just distributing in. There's my arrows there and there, distributing into those two terms there, and here into that x, and here into that 1 over there. Okay, so once I'm here, I'm going to collect like terms and solve for x. So I'm going to move all my x's to the left. That's going to get me negative x. And I'm going to move all my numbers to the right. That gets me negative 5. And of course, this means, to flip your signs, this means that x is equal to positive 5. And there we go. Today's lesson really is one of these questions down here. Solving exponential equations without a common base. So, in example A here, we have base 4 exponent x equals 12, and we're ultimately trying to find x there. So what can we do here? So the first thing I'm thinking of is if I can't solve that exponent because I know my exponents of 4 exponent 1 is just 4, 4 exponent 2 is already 16, so it can't equal to 12, so I know that that's probably a decimal or something there. Let's change this to something we can work with. If we can't work it in exponential, let's change it to logarithmic. So here in logs, I'm going to have x equals log base 4 of 12. And once I have this, I can solve for x. The way I'm going to solve for x is type it in on my calculator. So here we go, straight to my calculator. I have log base 4 of 12. There we go. That's equal to 1.79. And there we go. We are done. On this one here, I want to do something similar. So I got to, again, I'm trying to evaluate or figure out x there, solve for x. Again, it's an exponent, so I probably want to make this into a logarithmic equation. But the first thing I want to do is isolate my exponential function here. So I'm going to divide by 2 from both sides. So I'm going to divide by 2 here and divide by 2 over here. That gives me 3 to the 5x for an exponent equal to 6. And from here, I'm going to change it to exponential. So the way I do that is I'm going to switch this to become 5x equals log base 3 of 6. And of course, if we want to get x by itself, I'm going to divide both sides by 5, which is the same thing as multiplying by 1/5. So I have 1/5 log base 3 of 6. And whatever this works out to be, that should be my answer. So I'm just going to quickly check this on my calculator. So I have the 1/5, and then log base 3 of 6. So log base 3 of 6. Now that we have that all isolated, it's equal to 0.326. So x equals, so x here equals 0.326. There we go. In the next examples, here for C and D, notice that it's slightly different from A and B on the previous slide. So A was you had an exponential equal number, B was you had an exponential equal number. For C and D, you have exponential equal exponential. So the question is, how would we solve these ones? So we're going to use a new tactic. Right away, you can't really switch things around. So what I'm going to do is take the logs of both sides. And it's when I take the logs of both sides, that's going to be base 10. So I'm changing my base ultimately. So here we go. On the left, I'm just going to rewrite the left as log 5 of 3x is equal to log 3 of 2x minus 1. There we go. I'm just going to split my page in half here as well, just so that I can keep track of both sides. Once I have this, I have a logarithmic rule that says if I have a exponent here or exponent here, I can drop them down as coefficients. So basically, I'm going to move this 3x right in front of this logarithmic equation, and this 2x minus 1, I'm going to move it right down in front right here. And sorry, that's an arrowhead right there. I'm going to move it down right in front of the log. So if I rewrite this, I have 3x log of 5. And that's all equal to 2x minus 1. And yes, I put brackets on it because that whole binomial moved down in front, so it's a binomial here. Log of 3. From here, if I see a binomial times log of 3, I'm really going to distribute both of these with log of 3. So again, I'm just going to quickly rewrite. So I have 3x log of 5 here on the left, and nothing has happened there, is equal to 2x log of 3 minus log of 3, because negative 1 times log 3 is just negative 1 log 3. And from here, what I still want to do ultimately is still to find x. Reminder that we were trying to solve this question, so ultimately we want to find x. So what can I do? I'm going to move all of my x terms all to the left and keeping everything else on the right. Well, this here doesn't have, this second term here doesn't have any x's in it, so I'm just going to keep it alone. This I'm going to move over, so I'm going to subtract this logarithmic from both sides. So I have 3x log 5 minus, and here's the change up, minus 2x, oop, I forgot my x there, my 2x log 3. So I moved it from the right side all to the left. That's now going to be equal to my negative log 3. From here, again, ultimately our goal is to find x. So what can I do? If I have x in both of these terms, I can factor out an x. So if I factor out an x from these two terms, I'm left with 3 log 5 minus 2 log, oh, and I was missing a 3 here, minus 2 log 3. So I factored out an x to get x by itself there. All of this is still equal to that negative log of 3 there. From here, to get x, I'm just going to simply divide both sides by this giant logarithmic equation. So here on the left, I have x equals, on the right, I had that negative log 3, and that whole thing is now going to be divided by this giant double term. So we have our 3 log 5 minus 2 log 3. And I would leave my answer in this notation here, or if you're willing, you can type it in on your calculator and solve for x. And if you type this in on your calculator, and let me just show you how you do it, I would use the fraction function on your calculator. So I have my negative log 3 up top. On the bottom, I have my 3 log 5 minusing off 2 log 3. And here we get a final answer of negative 41,755. So x equals negative 0.41755. And I should round my answer to some sort of decimals there, but in this case they didn't tell us to how many decimals, so I'm just going to take a few of them there. For the next example, it's pretty much the same idea that we're going to work through. So this next example here, again, you don't have anything in common, you don't have common bases, so what can we do? I'm going to take the logarithm of both sides, log base 10 that is. So if I start this question off, I'm going to take the log of the left side, so I have log, let's change up our color, log of 3x plus 2, and on the right I'm going to take the log of 5 2x plus 3. And again, the same rule applies where if you had an exponent on your base there, you're going to drop them down in front. So here I'm going to rewrite this as x plus 2 log 3, and that's still going to be equal to this over here. I have a 2x plus 3 log 5. And from here, I'm going to try my best to solve for x, but what do I need to do first? I need to distribute on both sides. So on this one here, I'm multiplying x to log 3 and 2 to log 3. On this side here, I'm multiplying 2x to log 5 and 3 to log 5. Okay, so I'm just showing you a bit of my distribution arrows. So here on the left, what do we get? We get x log 3 plus 2 log 3. And on the right, that's equal to the right side, and our right side is now 2x log 5 plus 3 log 5. And now again, I want to try to get all my x's to one side and all my other numbers to the other. So here's what I'm going to do. I'm going to move this 2x log 5 all to the left, so I'm going to move this one to the left. And that means this one here, this number of without any variable, I'm going to move this log to the right. So what does that end up looking like? So here we have x log 3, and if I move this 2x log 5 to the left, now it's going to become minus 2x log 5. And I had that equal sign right there. And if I move this 2 log 3, positive 2 log 3 from the left to the right, it's going to become, so right now on the right side I already had my 3 log 5, and this is going to tack on the minus 2 log 3. There we go. And again, just like the previous question, what should we do here when we have two different x's? You're going to factor. So I'm going to factor out an x, and what does that leave me with? That leaves me with log 3 minus 2 log 5. There we go. And this is equal to still all of this here on the right side. So my 3 log 5 minus my 2 log 3. There we go. And from here, to get x by itself, I'm going to divide everything by this double term. So I'm going to go x equals, and here we go. Our final answer is going to look something like 3 log 5 minus 2 log 3. All of that is now being divided by log 3 minus 2 log 5. And there we go. We have our final answer. And again, you should try to evaluate this and solve for x. So let's try our best to plug all this into our graphing calculator and see what we get. And again, because this is kind of messy, I could do it either in 2 steps or just in one big step. And so I'm going to choose to do it in one step. So I have my fraction function. I have 3 log 5. Oops. And that's going to be subtracted by 2 log 3. And under that, I have my log 3 subtracted by 2 log 5. There we go. I hit enter, and that's going to be my final answer, negative 1.24. So x equals negative 1.24. There you go. So, by the way, we have two sets of answers, and I'm just going to try to denote both of them or give them names. This answer here is what we would call exact values. And this here, if I ever go to a decimal, this is approximate. On our next example, we have type 1, which is solving for log equations again. Logs are everywhere, so logs are on both sides already. Solve for x. Give your answer as exact value. So again, if I'm asking you for exact value, I am not looking for a decimal, the approximate value. I'm looking for something that looks like this, okay? So, for this first one here, I see log base 4 of 3x plus 2 equals log base 4 of x plus 6. So what can I do? Because if I have the logs, a single log on both sides, and they're the same single log with the same base, I can drop my bases. So once I drop my bases, I'm left with 3x plus 2 equals x plus 6. And this dropping bases is the exact same idea as when you drop the base if you had common exponents. Here I'm just going to isolate for x, so I'm going to move x to the other side. So I have 2x equals 4. And then of course, so here x is equal to 2, and there we go. We're done there. And that is exact value because x is only equal to 2. In example B, again, I'm going to take a look at my logs here. This one has a coefficient. I want to get it as a single logarithmic equation, so I'm going to bring that coefficient up. So on the left, I have log 3 of now x squared is equal to log 3 of 4. And again, because I have the same base, log 3, those will get knocked out. So I'm left with x squared equals 4. And of course, we're going to square roots here on the left, square root here on the right. But again, if I'm square rooting a variable, x is going to be equal to plus minus 2. And that's pretty much the answer. However, what we should do is always double check our answers to see if they are our solutions. And we haven't really done that yet this lesson, so let's just double check this one here in particular. So if I go to my calculator and I know my answer was 2 and negative 2, I'm just going to plug in my answer here. So if I have 2 math log base 3 of 2, there we go. And that should equal log base 3 of 4. And so that's what I want to check. So does this equal log base 3 of 4? Decimal wise, we match up. So 2 definitely is a solution. Let's try this exact same question now, but with a negative 2. So now I insert my negative 2, and let's see what happens if I hit enter. I get an error. Okay, I get an error. And there we go. There's that error again. So what's the difference between these two here? One, x has to be positive, so there's no way x can be negative. So here, um, because because x has to be greater than 0, because it has to be a positive value, x can only be equal to positive 2.